Alright gang, so here we are, the last chapter, chapter 12. And we're dealing with Nano server and Windows containers. Right. We're going to describe Nano server and its usage scenarios. We're going to install and manage Nano server. We're going to create advanced Nano server images, describe Windows containers and appropriate usage scenarios, and deploy Windows containers. And we're also going to manage Windows containers. So containers and Nano servers are distinctly different. So a common use for Nano server deployment is as a Hyper-V container, or Hyper-V or a container host. As a cloud-based application server, as a file server either part of a cluster or standalone, as a web server, or as a DNS server. So a Nano server is referred to as a headless server. No traditional user interface is built in to manage a Nano server. So there's a Nano server recovery console, and that allows you to perform basic initial configuration tasks, such as configuring a network interface and firewall rules, so it can be managed remotely. So a Nano server is bare bones, and it's designed to be managed remotely. So here's a Nano server recovery console. Okay. Now, Nano server excels at three of the most important qualities you want in a server: availability, low resource utilization, and security. Okay. Now, to install Nano server is not an installation option like Server Core or Desktop Experience. To install Nano server, you create a virtual disk from files included on your Windows Server installation media using PowerShell. You can install certain roles and features in Nano server while it's running. It's best to include them when you create the Nano server virtual disk. Now, you create a virtual disk from files included on your it's best to create them when you include them when you create the Nano server virtual disk. You can create a library of Nano server images with various roles already installed for easy deployment. There's no different requirements for those of Server Core than to a Nano server. You need 1.4 gigahertz 64-bit processor, 512 megabits of RAM. That's all minimum, and 32 gigabits available disk space. A base installation of Nano server actually requires less than those listed above. Now, you'll need Windows Server 2016 installation media, and the steps assume installation media are available on a Hyper-V server on a D drive. It will be copied to a folder named Nano server on the server's C drive. Now, copy the Nano server image generator files from the installation media. Okay, so here we are. We've got our Nano server, and here is the Nano server image generator. We can run it in import module PowerShell commandlet. New Nano server image, and then we just run right on down the line. All right, just have to determine the deployment type, the edition, target path, media path, base path, and computer name. Okay. Important differences in the new Nano server image commandlet: you got deployment type, OEM drivers, and compute. You don't need the media path. It was already specified in the base path parameter. Options for deploying it to a physical computer: dual boot on a computer that already has Windows OS on it. You can use PXE boot and WDS to install Windows Server on a bare metal computer. Use WinPE to install Nano server on a bare metal machine. Now, parameters you can use with the new Nano server image commandlet for adding roles and features. You've got storage, compute, defender, clustering, containers, and packages. Now here's the commandlets, and we've got a bunch more here. Okay. Adding packages adds only the binary files from the package to the Nano server image. You have to enable those features before you can begin using them, just like in the other server instances. Get Windows optional feature - online commandlet after you connect, and then we can also disable them. Okay, so here we go, importing and the get command. Here's some common configuration parameters for Nano server images, and here's some more. Now we've got two methods to join a domain, a Nano server to a domain. Join the same domain as a host computer, or to join a different domain. In both cases, you're performing an offline domain join, in which the Nano server will complete the joining process when it's first started. Offline domain join is a process that makes a computer a member of a domain without the computer having to contact the domain controller. Now we go ahead and use the commandlet domain name, domain to join option, where that's the name of the domain that we're going to join. Okay, there we go. It's all laid out there. Down blob. So there's some parameters we haven't talked about: copying files, debug method, driver's path, EMS port, reuse domain node. Like I said, probably a bunch of times now from the start of the course to now. Anytime you got a chance to use commandlets and PowerShell, use it. Okay. Go update them. Now, Windows containers. Now, it's a software environment in which the application can run, but it's isolated from much of the rest of the OS and other applications. Containers virtualize parts of the OS, allowing containerized applications to have their own copy of critical OS structures. Two types of containers supported by Windows Server 2016 are Windows Server containers and Hyper-V containers. All right. Benefits of using a container rather than a full VM. Containers use resources more efficiently while providing much of the application isolation provided by VMs. Scenarios when you consider containers rather than VMs. When you want to deploy similar applications that use the same OS kernel. When you want to package an application for fast deployment without worrying about dependencies or resource conflicts. And when an application consists of several lightweight components that can be easily scaled by adding additional containers. And Windows containers can be deployed on a Windows Server 2016 with desktop experience, Windows Server 2016 Server Core, or Nano Server. All deployments require the same basic steps. Configure the host OS as a container host, install Docker on the container host, install a base OS, create a Windows server or a Hyper-V container, and then manage the container networking, data volumes, and resources. Now, steps for implementing containers on Windows 16, desktop experience, and server core, they're the same using command line. We can use PowerShell, and it works just the same in either one. And here we are. To install it, to commandlets. We'll go ahead and restart the computer, and we're up and going. Now, we can check Task Manager. If we install Docker on a Windows 2016 container host, we can see it here. All right. Now, with the image downloaded, you can create a container using the Docker run command. You start a container based on a specified image, and that runs a command or an application. Now the following command uses Docker run command to start an interactive PowerShell session. So it's Docker run it. And then we have the rest of it here. If you want to see all the containers on the host as well as their status, it's Docker ps-a. You can create a container without starting it using the Docker create command. And then if you want to run it, just run the Docker run command. Okay, so here we go, creating a Windows Server 2016 container in PowerShell. All right. Now, if you want to implement containers on a Nano server, it's much the same as doing it on Windows Server 2016 Desktop Experience or Server Core. You've got to have the container feature in the Nano server image. You can install the container feature when you first create the Nano server image using new Nano server image with the -containers parameter. Now you can edit the image if you need to with the containers parameter. All right, so we should have gotten real strong on PowerShell by now, but like I said early on, there's a lot of PowerShell that we're covering. Okay. Now, this section looks at additional container configuration and management tasks using Docker as well as PowerShell. So there's several commands you can use to interact with and manage a container. You've got Docker PS, Docker RM, Docker stop, Docker start, restart, attach, exec, help, and then a Docker command with help. Okay, each one we've got a description of what it is, what it does. And here we are in PowerShell. Now, this section covers management tasks you use, like listing container images, tagging container images, committing container images, or changes to the images, or removing images. All right, we've got Docker images, and there they are. Just run the tag. All right, we can create that Nano server, commit, all right, get the Docker RMI. There we go. So we've got exec nano ps IP config through Docker. We can see the IP configuration of our Nano server or our container at that point on the Nano server. Okay. We'll deal with these in the lab. Here's some more PowerShell commandlets for managing containers. And there's some more. All right. We'll talk about Dockerfile, DockerHub, and Microsoft Azure. Now, Dockerfile, it's a feature of Docker in which you specify properties of a container image using a text file called a Dockerfile. So it's kind of like here's the data, it's in the text file, and that'll help it on the automated build. Then you use the Docker build command to create the new image, and it takes that Docker file and the information in it to create that customized container. So we've got add, command, copy from, run, user. Here we are in PowerShell. We've got DockerHub. It's a public repository of Docker container images. Anybody can create an account with DockerHub and upload saved images. Here we go. Docker push, DTOM show, DNS core. The Azure Container Service primarily focused on deploying clusters of virtual machines that are configured to run containerized applications. Now, these containers, it could be something as small as user authentication. You just want a little container taking care of that. And then if the number of users being authenticated grows, we'll just create another container. And these things are so small and they're so fast to roll out that it's nothing to it. We can have it sitting there ready, waiting and ready to roll whenever we need it. Okay, so here's our Azure Container Service. Now, Nano Server is not a general purpose Windows server, but it's intended to be used as a tool to deploy a single well-defined service. Nano Server excels at those three things: availability, low service utilization, and security. Now, containers are a type of virtualization. Windows 16 supports two types of containers. Windows containers can be deployed on Windows 20 Server 2016 Desktop Experience, Windows Server 2016 Server Core, as well as Windows Server 2016 Nano Server. Docker is open source software that's been used in the Linux environment to implement containers for years. To deploy a container, you install a base OS image using the Docker client. After you've downloaded an image, you can create a Windows Server 2016 container by using the Docker run command. Docker.exe program is the primary tool for working with containers. So just think, Docker, containers. We can't be dealing with containers unless we've got Docker. Docker configures the container network using NAT. DockerHub is a public repository for Docker container images. So go ahead and move on to the reading, as well as the flashcards and the crossword puzzles before you take that quiz, and make sure that you're well versed when you're going through that Chapter 12 virtual lab. Okay. It's been great. I may see you in another video coming.